Okay, so in the previous videos talking about functional dependencies, we talked about identifying sets of functional dependencies related to a particular domain. Now an example might be a set of functional dependencies like this, where we come up with these dependencies by thinking about the problem and saying, well, if I've got a combination of A and B, that determines C. If I know A, well, that also determines C, and if I know B, that determines C. So a question that arises, you can come up with many, many sets of functional dependencies. So a question that arises is, what's the minimal set of functional dependencies? And that is called a minimal cover. So a set of functional dependencies that is equivalent to your original set but contains less stuff. So if we look at this example here, we could see that given AB determines C, and given A we know C, then in some sense B is a little bit redundant in this particular functional dependency. So if we wanted to, without changing the expressive power of the set of functional dependencies, we could actually remove that. Now, having done that, we end up with two identical functional dependencies. So they're a little bit redundant. You don't need to have the same one twice. So we could get rid of that. And that gives us A determines C, B determines C. And those two functional dependencies ought to be equivalent to the original set of functional dependencies, but clearly they're smaller. So the idea of minimal cover is to find an equivalent set of functional dependencies for a given set F such that all of the dependencies have a single attribute on the right hand side, and there are no redundant dependencies in the set. And also that there are no redundant attributes on the right-hand side like there were in that case. Okay, so let's consider how we might do that. And there's a standard algorithm for doing it. Okay, so the standard algorithm for producing a set of a canonical cover or a minimal cover from a set F. So what we're trying to do is take a set F and turn it into an equivalent version that is in some sense smaller and is the smallest possible thing that we can come up with. So the way we start is that we take all of our functional dependencies and we convert them to the form where A is a single attribute. Remember that when we're talking about functional dependencies, we'll often write a letter like X or Y to indicate a set of attributes. So all the functional dependencies have to be converted to the form where we've got a set of attributes on the left-hand side and a single attribute on the right-hand side. The next thing to do is to remove redundant attributes there. Oh dear. Remove redundant attributes from the left-hand side of all of the functional dependencies. How do we know they're redundant? Well, we know they're redundant if we take them out and the set of functional dependencies still gives us the same result. So we can work that out by taking an attribute closure, or if you're really keen, a functional dependency closure. So that's going to convert all of our original FDs to a particular form. This is going to make them smaller in the sense that we're removing stuff that we don't need from the left-hand side. And the final thing we do, having done all that, we might end up with some redundant are FDs. And how do we know they're redundant? Well, once again, if we take them out and we still get the same attribute closure or the same dependency closure, redundant FDs are removed. So if we do these 3 steps, we're going to end up with a minimal cover FC, which is equivalent to our original set of functional dependencies, but is smaller in some sense. So let's take a look at an example. So our starting set of functional dependencies will be B determines C, A determines C, so straight away we can see that we've got that scenario that I originally had, where there's a bit of redundancy, like that B is redundant. Okay, so that's our original set of functional dependencies. We want to make it smaller. Well, the first thing we can do is we need to convert all of the dependencies to a form where they've got a single attribute on the right-hand side. Well, this one clearly doesn't, but it's very easy to convert it to the appropriate form, and that's simply to write these 2 dependencies. Okay, so in theory we've completed step 1. Next thing to do is to, and this you can edit out while I work out what I'm saying. The next thing to do is oh, bugger. In fact, we're going to have to go back a little bit because I had the wrong original set, but you should be able to work out where to go back to. The original set. Okay, so this isn't in a form that satisfies condition number 1, or it's not at the end of condition number 1, but we can easily put it into a form like that by simply splitting up that functional dependence. And we saw why those 2 things were equivalent, or why this pair of functional dependencies was equivalent to what I originally had. We saw that in the previous example. Okay, next thing to do, start removing redundant attributes from the left-hand side. Okay, well there's not many choices there, but certainly we saw before that that was a redundant attribute. So AB determines C, but A by itself determines C, so we don't need B. So that's the sense that it's redundant. All right, well what that gives us, it gives us 2 occurrences of A determines C. Obviously one of them is unnecessary, so if we remove that, we end up with A determines C, D determines A, D determines E, and I don't think that we can remove anything else without changing the meaning of the set of functional dependencies. So here's our final set. Now one thing you might notice is that all references to B have vanished from the set of functional dependencies. Now the reason for that could be that B isn't really that important in the relationship between the attributes in the table, so it doesn't matter that it's gone. We'll see that it may have to come back later on. So that's how we convert a set of functional dependencies to a reduced, or in other words minimal set of functional dependencies which are equivalent to the original set.